Good. How's the math going this year?
A lot better.
Good. Very good to hear. Okay, I got these documents. Hold on a moment. I got to get my thing to work here. There we go. All right. You want to start here?
Yes, please.
All right. Let's see. Let me put my... Let's start at the top. What's the first step I want to do here?
I don't have to do that problem. I just have to do number 2, 3, and 4 on this page. Because I understand that one.
Okay, that's fine. Okay, how do we multiply 2/3 times 5/6?
Straight across.
Yep. So what does that equal to?
10 over, wait. 10 over 18.
And that needs to be reduced. So how can we reduce that?
Divided by 2.
Okay, so what's that equal to?
5 over 9.
Okay, so that is the simplified answer. But notice there are some shortcuts that I can do here that actually are beneficial. They make things easier. One is that I notice that 2 over 6 is the same as 1 over 3. In other words, I can divide the top by 2 and the bottom by 2. When I divide the top by 2, I get that. When I divide the bottom by 2, I get that. Now when I multiply straight across, I don't get 10/18. I get 5/9. So
Okay.
I find it far simpler to do whatever simplification you can before you multiply straight across. Okay? I'm sure we'll see more examples. I'll point it out. It's really not any more work, and it's probably a little less work. So how do I do this one?
Flip 3 this, 5 over 3.
And change it to multiply. Okay, now let's use that little technique. In other words, if you multiply it straight across, you're going to get 30 over 75. That's going to be harder to simplify than by reducing some where we can here. What can we simplify?
5 and 25, and then 6 and 3.
Okay, so 5 and 25 becomes what?
1 and 5.
And 6 and 3 becomes what?
2 and 1.
So our answer is what?
2/5.
How much easier it is? And the beauty of doing that is that you never deal with the bigger numbers. Notice that we never dealt with a number bigger than 5. Whereas had I multiplied straight across, I would have had 30 over 75, much bigger numbers, much harder to reduce to 2/5.
Oh, okay.
Okay, now we're going to add. Adding or subtracting fractions is actually far more difficult than multiplying or dividing them. Because we have to find a common denominator. So what's the least common denominator for this one?
6.
Okay, so each one has to have a denominator of 6. Well, this one already has that. So what is this new numerator?
4.
And we got that by multiplying this by 2 over 2. In other words, you can always multiply a fraction by the number 1 without changing its value. And when you do that, you get 4 over 6. So now what is this equal to?
9 over 6.
Right. The denominator stays the same, and you just add the numerators. And then that reduces to what? Still there? Marina, I lost. You back? Marina? I can hear you. I can hear you now. I lost you for a moment.
Sorry, no, accidentally unplugged.
I didn't hear what you said. What happened?
Accidentally unplugged it.
Oh, okay. So 9 over 6, how do we reduce that?
3 over 2.
Okay. Oops, hold on. All right, this a little harder. What's the least common denominator?
40.
Remember that the least common denominator has to be divisible by both terms.
I mean 45.
45. So this one is 45, and this one is going to be 45. So how much is 8/9 in terms of 45?
40 over 45.
Okay. You divided that into that, multiplied it by that. And how about 3/5?
27 over 45.
So that answer?
13 over 45.
And can that be reduced?
Nope, I don't think so.
No, you're right. 13 is prime. In other words, nothing divides into 13, so the only way this could be reduced is if the bottom was some multiple of 13, like 26 or something. Then we could reduce it. But since the bottom's not a multiple of 13, it can't be reduced.
Okay. Can we go on to number 3? Because I think I have.
Absolutely. I was just going to say, you seem like you know these. Let me just check one last thing. Let's do this one for accelerated students. Are you supposed to be able to do all of these?
Yeah. Most of it's review.
What's the common denominator here?
For 3 or 4?
For 4 over y plus 3 over x. If I'm going to add those two fractions, I got to find a common denominator. What is it?
Yx.
Okay, that's good. So what is the numerator going to be on the term on the left?
4x.
And the term on the right?
3y.
So our answer?
4x plus 3y over yx.
Very good. You do know how to do all of those. Okay, just checking. Alright, 5 times the sum of b and 6 is equal to c squared. How do I write that into an equation?
Uh, 5 times, would be parentheses,
Yep.
b plus 6, parentheses equals c squared.
Good. How about the next one? 8 increased by the product of 2. Oh, excuse me. 8 increased by the product of 2 and d is equal to 1/3 of f squared.
I don't get that.
Well, it's a little hard. Let's take it one at a time. 8 increased, so it's going to be 8 plus. The product means to the two things multiplied together. So when they say the product of 2 and d, they mean that. That could be called the product of 2 and d. And it's equal to 1/3 of means multiply f squared.
Oh, okay.
Okay? Okay, now here's the only place you have to be really careful is when you see this. And they always word these like this. When you see a word problem that starts out some number less than something else, it is never going to be 10 minus. It's going to be that something else minus the 10. In other words, the last problem, you'll notice I started out by writing 8 plus. I can do that as long as it's increased. When it's less than, I can't do that. The less than goes behind whatever it's being subtracted from. So it's 10 less than, how do I write the quotient of b and 12? What does that mean? The quotient of b and 12.
Is quotient division?
So it's b over 12. Okay. Is the same as what?
2b.
Right. Now, notice how easy it would be to make this mistake. This is what probably half the people will do, because you're inclined to start from the left and move to the right. But the key word here is this than. It's not 10 less the quotient of b and 12, otherwise this would be correct. It's 10 less than the quotient. In other words, if I said you are 40 years less old than me, it would be my age minus 40 to get your age. It wouldn't be 40 minus my age. So when you see the terms less than, know that you're going to be subtracting from whatever it's less than.
Is that the same for addition? Because in problem D it says more than, so it'd be like x plus.
Yeah, the difference is this. When you're adding, you can switch them and it won't matter. When you're subtracting, it definitely matters. In other words, when I say 3 more than 5 times a number, I'm saying 3 more than 5 times a number. But I could have written it like this just as easily and it would be just as correct. But when I say 3 less than 5 times a number, only this is correct. If I say 3 less than 5 times a number and write it like that, that's a different thing. Those are not the same. When you have subtraction taking place, you can't switch them. The order is all important.
Okay.
So we did D. How about E?
X minus 6.
6 less than twice a number. Incorporate.
X squared.
No, twice. Twice means times 2.
2x.
So it's 2x minus 6. And F, 7 more than a number.
X plus 7.
Yeah. Okay. Solve each for the indicated value. Okay. To do these, you need the general formula for the area of a triangle. What is it?
A squared plus b squared equals c squared.
And that's a right triangle only, and that's the relationships of its sides. It's not the area. The area is something very specific. It's 1/2 the base times the vertical height. So there's 3 variables in this equation. There's area, there's base, and there's height. If we know any 2, we can figure out the third by algebra. In other words, you give me a base and a height, and I'll give you the area. You give me an area and a base, I'll give you the height. So what have they given us here?
Area and the base.
Okay, so let's fill it in. What's the next line?
48 equals 1/2 times 12 equals h.
Times h.
Times h.
Okay. So now reduce on the right side. Before we go solving this, let's apply the same methods. Let's try to reduce whenever possible. What is 1/2 times 12?
6.
Okay, so I'm going to cross that out, replace that with a 6. Now h is going to be what?
8.
Good. Okay, shaded region problems. Let me reposition my whiteboard. I generally tell everybody that shaded region problems are subtraction problems. Because we don't really know, we're not taught the geometry to figure out the area of this strange shaped thing here. That's not rectangles or squares or triangles. However, we can figure out the area of the entire outside thing, which is just a combination of 2 rectangles. And we can figure out the area of this white triangle. So the shaded region, the area of the shaded region is equal to the area of the outside minus the area of the triangle. Right?
So everything that's shaded minus the area of the triangle?
No. Everything on the outside minus the area of this triangle will give us the shaded region.
Okay.
Okay? You get that?
Yeah.
Okay. So first of all, let's figure out the area of the whole outside thing. And as they suggest, we need to figure out what these question marks are here. So how far is this distance here?
Which one?
This lower question mark, can you see my cursor right there?
Yeah.
How far is that?
2 centimeters.
Okay, notice this 13 is just from here to here.
Oh.
So what's this total top?
5 centimeters.
This is 5 here. Because this total top is 16, this here is 11, subtract the 2 to get that. So, here, let me draw this, I guess.
I got 5.
Yeah, that's
Like
correct.
16 minus 11 is 5.
Yeah, that's correct. Okay. And what is this dimension right there?
4 centimeters.
Yeah, so we know that because this one's 9 and this one's 5, so 9 minus 5 is 4. We can't assume it's 4 just because this says 4 over here. We don't know for certain that that line would hit exactly there. But we do know that that side's 9 and we know this side is 5, so this has to be 4.
Okay.
Alright. This is 13, this is 11, this is 5. So, we're going to break this up into 2 rectangles. Ignore the triangle for the moment. What is the area of this long rectangle?
20.
16 by 4. Base times height.
Oh. I did 3.
In other words, I'm talking about this whole rectangle.
Oh, 64.
Okay. What's the area of this lower rectangle?
55.
What is the area of the outside? This is what I call the whole thing.
119.
Now, if we can figure out the area of that triangle, we'll subtract it and we'll have the area of the shaded region. So what's the area of that triangle?
1/2 base times height.
Which is? Okay. So 119 minus 6 is the answer. 113 is the area of the shaded region. Notice that the area of the shaded region is 6 centimeters less than the area of the whole outside. There wasn't much in that white area, just 6 centimeters worth. 6 square centimeters, excuse me. Okay, next page, I assume?
Yes.
Okay, that was photo 1. Let's try photo 2 here. Where do you want to start here? With 10?
10A.
10A, okay. Still with me?
Yes.
Sounded like I lost you there for a moment. All right, pick a variable for the number of weeks and another variable for the total in the bank. Go ahead and you can pick any variable you want. Pick a variable for the number of weeks.
5.
A variable.
Oh, X.
So X is the number of weeks. And how about the total in the bank?
Y.
You can pick anything you want. There's no right or wrong on this. Total in bank. Some people might have picked W for the number of weeks and B for the total in the bank. But I got no problem with X and Y. I love X and Y. All right. So that's done. Make a table showing Marcy's account balance after 0, 1, 2, 3, 5, 10, and 72 weeks. I'm going to make a table right here. Got X and Y. We got 0, 1, 2, 3, 5, 10, and 73. What is her bank balance after 0 weeks?
12.
What's her bank balance after 1 week?
Wait, how much did you say?
She stays $5 every week up here in the top.
Oh, okay, I see it. 17.
And 2 weeks.
22.
And 3 weeks.
27.
And 5 weeks.
32.
She saves 5 every week, but 2 weeks have taken place here.
Oh, 37.
How about by 10 weeks? How much? The way to figure this is to figure out how much she saves in those 5 weeks between 5 and 10. And add it to the 37.
So you got 37 plus 50.
Okay, there's 5 weeks between weeks 5 and 10. She saves $5 per week. How much does she save in that 5-week period?
Oh, 25.
So I got to add 25 to, yes. Okay. Now to get the 73, do the same thing. What did we do? We subtracted these two numbers and we multiplied by 5, and then we added it to that.
It'd be 315 plus. It'd be 352.
Well, you were right with the 315, but then we're going to add it to 62, which is 377.
Okay.
Okay?
Alright.
Okay. D, describe in words how to calculate Marcy's balance if you know the total number of weeks. So let's describe it in words. Y is equal to what?
The total cost of the bank.
Well, how about what we started with? 12 plus what?
Plus 5.
times
X.
the number of weeks. Right?
Yeah.
In other words, we could have figured out the 73 by doing that. We could have said that after 73 weeks, she's going to have a balance of 12 plus 73 times 5. And we would have gotten that same answer, 377. You and I constructed this table a little different, but not that different. We just did the difference between the previous weeks. You can do these things any way you want, but the fact of the matter is that the amount she has in the bank is going to equal to $12 plus the number of weeks times 5.
Okay.
Now, write that equation. What does that mean? That she's going to have $12 plus the number of weeks times 5. What's the variable that represents the number of weeks?
X.
Okay, so let's write out the equation exactly as I said it. She's going to have $12 plus $5 times the number of weeks. So how does that translate into an equation? Y equals
5x plus 12.
Well, the way I actually said it was like this. Now, they want it in y equal mx plus b format, so I would have to switch it around. So that is, in fact, the correct answer, but it's better if you follow the way you state it and then switch it around. In other words, the exercise here is to take a word statement and convert it directly to an equation. Then do with it what you have to. But in terms of converting that word statement that we came up to into an equation, it was y equals $12 plus 5 times the number of weeks. Then we switch it into mx plus b format.
Okay.
Okay? That's just the easiest way to do it.
Could we move on to number 11? Because
Yeah.
I
Yep.
need help in that one the most.
Yep.
11, 12, and 13 are the ones I'm struggling on.
Okay. Let's talk about functions first of all. That is a function because it passes the vertical line test. In other words, what that means is that for a given value of x, I have at most one value for y. In other words, when I go to this value of x, I don't have two values for y, I got one value right there. That makes it a function. If instead I had the following, that does not pass the vertical line test. If I draw a vertical line right through there, I get more than one value for y. In other words, the reason this fails is that for this particular value of x, I have multiple values of y. So all you have to do is find 2, and it's not a function. Okay?
Okay.
So a circle is not a function. That fails the vertical line test. So when we're looking at a table, remember our definition. For a given value of x, we can have at most one unique value for y. Does this table A violate that?
A? No.
This one right here. Is there a value of x? Is there a value of x that gives two different values for y?
Yeah, one does.
Yeah. In other words, this doesn't violate it. It's fine to have the same value of y for two different values of x. That's still a function. But we've got 1 equals 2 there, and down here we got 1 equals 3. So if I was graphing that, I would go to the spot on the x-axis that's 1, and they're telling me, well, when x is 1, y is 2 in one case, and it's 3 in another. Well, immediately that violates the vertical line test.
So would I say for the explanation that no, it is not?
It's not a function. Explain why it isn't or why it is. And we just did that. It's not a function because for an x value of 1, there are two different values for y.
Sorry, can you repeat that again?
For the value for x equal 1, we had two different values for y. That violates the rule for a function. Okay. B is the same thing as A, only instead of a table, they separated it into two, and they're telling us that 3 goes with the 10, 2 goes with the 12, 5 goes with the 8, this 3 goes with that 10, 7 goes with that 10, and 9 goes with the 6. So I could write a table from this that looks just like this. The fact that this is domain and this is range doesn't matter. Domain is the values that x can take on. Range are the values that y can take on. So, is this a function or not?
Yes, it is.
Yes. Because, and the because is important, because for every value of x, in other words, for every value in the domain, you have a unique value in the range. 3 is equal to 10, 2 is equal to 12, 5 is equal to 8, 3 is equal to 10 again, that's fine, same number. 7 is equal to 10, that's fine. Notice that we can have 3 and 7 both be equal to 10. There's 3 on the x-axis, there's 7. So 10 is up here, that's fine. That doesn't violate the vertical line rule at all. In fact, if I want to draw a function through that like that, in other words, when x is equal to 3, y can be equal to 10, and when x is equal to 7, y can be equal to 10. That's perfectly fine. And nowhere on there do we have two different values, do we have the same value in the domain equal to two different values in the range. Therefore, it is a function. About C.
It's not.
Because?
Because the x value of 8 has two different values for y.
Good. That's all you need to say. And that actually is the only reason it isn't a function, is because of that right there. How about D?
No, because the 7 has two y values too.
Correct. About E?
No, because yes. Because the 7 value has all the same y values.
Yeah, so it is a function. It's a function made up of one point only. When x is equal to 7, y is equal to 3. You can repeat it as often as you want. It doesn't change anything. In other words, it's just that same point over and over and over again, but it's only one point on your curve. And f, down here, the graph. I like this, what they're doing here. They're giving you functions in all kinds of different types. When you connect the dots on f, does it pass the vertical line test?
No.
So therefore it is not a function. Or you could say when x has a value of 5, y has two different values. About g.
Yes. Oh, just say no.
Why'd you say yes quickly?
Because I didn't see the other 5.
Because you only saw one value for x. In other words, there are no multiple values of x. Or, I'm sorry, there's no same values of x. That 2 is different than that 5, is different than that minus 1, is different than that 0. Oops, here we go. I'm sorry, I didn't see this. So we have 5 equal to 2, and we have 5 equal to 3, therefore no. Yeah, my mistake. I thought it was. About h.
No, because they're the same x values, different y's.
That's right. How about I?
Nope, because it doesn't pass the vertical line test.
Right there only. Yeah. Okay, 12. Hold on. Okay, f of x equals 2x plus 7. What does this mean? F of 3. If you don't know, take your wildest guess, and it's going to be right.
Um, 11. Or just
You meant to say 13. I know you did. In other words, you plugged in 3 for x, right?
Yes.
That's what you always do. In other words, what is f of 4? 2 times 4 plus 7, 15. Okay, now let's make it a little harder. What is f of x minus 1?
Well, what does x equal?
Well, you use exactly the same strategy. You take whatever's inside the parentheses and you plug it in for x. So it would be 2 times x minus 1 plus 7.
So it would be 2x minus 2 plus 7.
Which is 2x plus 5. The principle is that when they give you a function of x, and then they say, what is f of something else? This thing can be a number, it can be another function, it can even be g of x. So what you have to understand is that whatever's inside the parentheses gets plugged in for x, no matter what x is.
Okay.
So here we have a different function, g of x, and it's equal to minus 3x plus 5. So what is g of minus 2 equal to? Do it in steps. Tell me, in other words, plug it in first, and then we'll do the arithmetic.
Negative 3 times negative 2 plus 5.
Yeah, that's always the way you want to do it. You don't want to try to do these all in one step. What's that?
5 plus 5.
It's 3 times 2.
Oh, sorry. 6 plus 5.
Okay. You know absolute value. You know what that means, right?
2 bars.
Uh-huh. This next one is that. What is h of minus 3?
2 absolute value, negative 3 plus 7.
Next line.
2 absolute value of four.
And the final one.
2 times 4 equals 8.
Okay. What is h of minus 10?
Uh, 2 times negative 10 plus 7. Negative 3. Which equals 6.
Positive 6, because the absolute value of a negative number is positive. In other words, absolute value merely says just take the number and make it positive. If it's negative, make it positive. Okay? And last D. I'm going to call this W of X. You can call these anything you want. What is W of minus 2?
Negative 2 plus 5 plus negative 2, minus negative 2 squared. Yeah.
Very important to use the parentheses there. If I don't use the parentheses, it's a different answer. When I've got the parentheses in there, I'm squaring negative 2. If I were to write it like this, all I'm doing is squaring the number 2, which this would equal minus 4. This equals plus 4. So what's the next line?
3 value.
And we can drop the absolute values at this point.
Okay, plus 4.
And it is a plus. Like I said, when you square that, it turns plus. To plus 4. All right. Is that the end of that page? Okay. It's 2 minutes to 5. You want to stop there? Let's see. Do you and I have another appointment scheduled before your exam, or is this
We could make one for tomorrow because my math exam is on Thursday.
Well, we'll see if I have any time tomorrow. I'm pretty swamped this week. My Wednesday evening is full from 3:30 to 9. So if you want one tomorrow, it's going to have to be before 3:30.
Hold on, let me ask my mom.